Stop what you're doing for a second. Just stop. You think you're sitting still right now, don't you? Maybe on your couch or at your desk, just chilling and watching this video. But here's the truth. You're spinning. Right now, at over 1,000 kilometers per hour. And it gets crazier. The Earth is spinning around the Sun. The Sun is spinning around the galaxy. The galaxy itself is spinning. Even the atoms in your body, they're spinning too. Everything in the universe is spinning. Every single thing. And when Richard Feynman looked into why this happens, what he found was so weird, so fundamental, it literally explains why you exist. Let me show you something that's going to completely change how you see the universe. All right, let's start simple. Planet Earth. Right now, you're standing on a ball of rock that's rotating at about 1,670 kilometers per hour at the equator. That's faster than the speed of sound. You're basically on a supersonic merry-go-round. But you don't feel it, right? Everything feels still. That's because you, the air, the buildings, everything around you is all spinning together. There's no wind in your face because the atmosphere is coming along for the ride. Now here's the question nobody really asks. Why is Earth spinning? Most people think, oh, it's just leftover momentum from when the planet formed. Like when you spin a basketball on your finger and it keeps going. And yeah, that's part of it. But that's not the real answer. Because here's what's weird. Earth isn't slowing down. Well, it is, but incredibly slowly. Like a few milliseconds every century. At this rate, it'll take billions of years to stop. But why? Why doesn't it just stop? I mean, if you spin a ball and let it go on the ground, friction stops it pretty quick, right? Earth has friction too. The oceans slosh around, the moon pulls on it with gravity, creating tides. All of that should slow us down way faster. So why are we still spinning after 4.5 billion years? The answer is something called conservation of angular momentum. And trust me, this is where things start getting really interesting. See, once something starts spinning, it wants to keep spinning, forever, unless something actively stops it. Think about an ice skater. When they're spinning with their arms out, they spin at a certain speed. But when they pull their arms in, they spin way faster. Same amount of spin, just concentrated into a smaller space. That's angular momentum. And the universe has a rule. Angular momentum never just disappears. It has to go somewhere. Earth is spinning because when our solar system formed 4.6 billion years ago, it was a giant cloud of gas and dust. And that cloud was spinning. Just a little bit. Maybe from a nearby supernova explosion, or from the galaxy's rotation, or from random turbulence. Doesn't matter. What matters is this. When that cloud collapsed under its own gravity to form the sun and planets, it got smaller. Way smaller. And just like that ice skater pulling their arms in, it started spinning faster. The sun got most of the mass, but the planets got most of the spin. And Earth has been carrying that spin ever since. But here's where it gets absolutely wild. It's not just Earth. It's everything. Let's zoom out. Our sun, spinning. Takes about 27 days to complete one rotation. Our entire solar system? It's orbiting around the center of the Milky Way galaxy. One complete orbit takes 230 million years. The last time we were in this exact spot in space, dinosaurs were just starting to show up on Earth. The Milky Way galaxy itself? Spinning, like a massive cosmic pinwheel. The whole thing rotates once every 250 million years or so. And it's not just our galaxy. Every galaxy we've ever observed is spinning. Andromeda? Spinning. Triangulum? Spinning. Those distant galaxies billions of light years away? All of them. Spinning. Even galaxy clusters, groups of hundreds or thousands of galaxies, they're rotating around their common center of mass. Go smaller. Look at stars being born. They form from collapsing clouds of gas, right? And every single one of them starts spinning as it forms. Not sometimes, not usually, always. Planets? All spinning. Moons? Spinning. Asteroids? You guessed it, spinning. Go even smaller. Inside atoms, electrons aren't really orbiting the nucleus like planets around the sun, but they do have something called spin. It's a quantum property, but the name fits. Even subatomic particles have spin. Here's what's absolutely bonkers. We have never found anything in the universe that isn't spinning or doesn't have angular momentum. Not one thing. Why? I mean, think about it. The universe could have been different. Things could just move in straight lines or sit still or wobble randomly. But no, everything spins, everything rotates. There has to be a reason. And this is where Feynman comes in with something absolutely brilliant. Richard Feynman had this way of looking at physics that was different from everyone else. He didn't just ask, how does it work? He asked, why does it have to work this way? So when it came to rotation and spin, Feynman pointed out something most people miss. Sitting still, perfectly still, is actually the hardest thing to do in the universe. Think about it. For something to be perfectly still, it would need to have zero angular momentum. Not a tiny bit. Exactly zero. Perfect stillness in every possible direction. But here's the thing. The universe is noisy. It's chaotic. There's always something pushing, pulling, nudging. A gravitational tug from a distant star, a passing particle, a quantum fluctuation. Any tiny little push, no matter how small, and boom, you've got angular momentum. And remember what we said earlier. Angular momentum is conserved. Once you have it, you can't get rid of it. It's stuck with you forever. So in practice, nothing is ever perfectly still. Because perfect stillness is insanely fragile. One tiny disturbance, and it's gone. But spin? Spin is stable. Once something is spinning, it stays spinning. It's robust. It resists change. This is why everything in the universe spins. Not because spin is special, but because not spinning is basically impossible. Feynman used to explain it like this. Imagine you're trying to balance a pencil perfectly on its tip. Theoretically possible, right? But in practice, the tiniest vibration, the smallest breath of air, and it falls over. That's what zero angular momentum is like. Theoretically possible, practically impossible. But here's where Feynman went even deeper. He looked at why angular momentum is conserved in the first place, and the answer is so beautiful, it's almost poetic. See, there's this thing in physics called Noether's theorem. It was discovered by a brilliant mathematician named Emmy Noether. And what she proved is that every symmetry in the universe corresponds to a conservation law. For example, the laws of physics are the same today as they were yesterday, right? Time doesn't change how physics works. That symmetry, the fact that physics is the same at all times, that's why energy is conserved. Space works the same way everywhere, right? Physics in New York is the same as physics in Tokyo. That's symmetry. Physics being the same everywhere in space, that's why momentum is conserved. And here's the beautiful part. Physics is the same no matter which direction you're facing. North, south, east, west, up, down. The laws of physics don't care about direction. That rotational symmetry, that's why angular momentum is conserved. The universe doesn't have a preferred direction. There's no cosmic north or cosmic up. Every direction is equal. And because of that symmetry, angular momentum can never be created or destroyed, only transferred. This is why everything spins. The universe itself, through its very structure, its fundamental symmetries, guarantees that spin is eternal. But it goes even deeper than that. Okay, so everything spins, but so what, right? Why does it matter? Oh man, it matters more than you can imagine, because spinning is literally what creates structure in the universe. Let me explain. When the Big Bang happened, the universe was basically uniform. Just a hot, dense soup of energy and particles spreading out in all directions. No galaxies, no stars, nothing, just smooth chaos. But it wasn't perfectly smooth. There were tiny little density fluctuations. Some regions had slightly more matter than others, and those regions had slightly more gravity. Now, here's where spin comes in. As these denser regions started to collapse under their own gravity, they started spinning. Had to, because they had angular momentum. And here's the key. When something spins while it collapses, it doesn't collapse into a point. It flattens out into a disk. Think about pizza dough. When you spin it, centrifugal force pushes the edges outward and flattens it. Same thing happens in space. This is why galaxies are flat spirals, why solar systems form as flat disks, with all the planets orbiting in roughly the same plane. Why Saturn has those beautiful rings. All of it, the entire structure of the universe, exists because of spin. Without rotation, everything would just collapse into spheres or clumps. No disks, no spirals, no elegant structure. Just boring blobs of matter. But spin creates organization. It creates patterns. It creates beauty. And here's something even crazier. Spin is what makes planets habitable. Think about Earth. We have day and night because we spin, right? But it's more than that. Our spin creates our magnetic field. See, Earth has a liquid iron core. And as the planet spins, that liquid metal swirls around, creating electric currents. Those currents generate a magnetic field that surrounds the planet. And that magnetic field? It protects us from deadly solar radiation. Without it, the sun would strip away our atmosphere and sterilize the surface. Mars lost most of its atmosphere because its magnetic field died when its core cooled down. It stopped spinning internally, and now it's a dead world. Spin literally makes life possible. And it's not just planets. Stars need to spin too. When a star forms from a collapsing gas cloud, the spin creates a disk of material around it. And from that disk, planets form. No spin, no disk. No disk, no planets. No planets, no us. Every single thing that makes the universe interesting, galaxies, solar systems, planets, magnetic fields, day and night cycles, all of it exists because of spin. But there's one more layer to this, and it's the wildest one yet. All right, we've talked about planets spinning, stars spinning, galaxies spinning, but now we need to go really small. Down to the level of atoms and particles. Because even there, at the tiniest scales imaginable, things are spinning. And it's absolutely insane. Electrons have something called spin. Now, they're not literally spinning like a top. They're too small for that. They're not even really solid objects in the normal sense. But they have a property that behaves exactly like angular momentum. So we call it spin. And here's the weird part. Electron spin only comes in two values, spin up or spin down. That's it. No in between. It's like if you could only spin clockwise or counterclockwise, but never at different speeds. Just those two options. This is pure quantum mechanics, and it's one of the strangest things in all of physics. But here's why it matters. Electron spin is what makes chemistry work. See, there's this rule called the Pauli exclusion principle. It says that two electrons can't be in the exact same quantum state in the same place. They have to differ in some way. And one of the ways they can differ is their spin. One spin up, one spin down. This is why atoms have electron shells, why elements have different chemical properties, why molecules form the way they do. Without quantum spin, electrons would all collapse into the lowest energy state. Atoms wouldn't have structure, chemistry wouldn't exist, and neither would you. Your entire body, every protein, every DNA molecule, every cell, exists because electrons have spin. Feynman loved this stuff. He once said that quantum spin is the most purely quantum mechanical thing in all of physics. It has no classical analog. It's just weird. But it's also fundamental. Protons have spin. Neutrons have spin. Even particles like quarks and neutrinos have spin. And get this, particles with different spins behave completely differently. Particles with half-integer spin, like electrons, are called fermions. They follow the Pauli exclusion principle. They're the building blocks of matter. Particles with integer spin, like photons, are called bosons. They don't follow the exclusion principle. They can pile on top of each other. They're the force carriers of the universe. Matter versus forces. Structure versus interaction. All determined by spin. And here's the absolutely mind-bending part. We still don't fully understand why particles have spin. We know that they do. We can measure it. We can use it. But the deep reason, the fundamental explanation of what spin really is at the quantum level, we're still figuring it out. It's one of the deepest mysteries in physics, right up there with why does the universe exist and what is consciousness? Spin is woven into the very fabric of reality, and we're only just beginning to understand what that really means. Okay, let's zoom all the way back out. We've gone from quantum particles to planets to galaxies. But there's one more thing we need to talk about. The universe itself. Is the universe spinning? This is actually a serious question in cosmology, and the answer is, we don't know for sure. But probably not, or at least not much. See, when we look at the cosmic microwave background, the afterglow of the Big Bang, it looks pretty much the same in all directions, no sign of overall rotation. If the universe was spinning, we'd expect to see patterns, spiral structures on the largest scales, temperature differences in certain directions. We don't see that. So most scientists think the universe as a whole isn't rotating. Or if it is, it's spinning so slowly we can't detect it yet. But here's what's fascinating. Some scientists have suggested that the universe could be spinning, and we just can't tell because we're inside it. Like, imagine you're inside a giant rotating sphere. If everything inside is rotating together, you, the stars, the galaxies, even light itself, how would you know? You'd need something outside to compare to. We don't have that. We only see the universe from inside, so it's possible that the entire cosmos is rotating around some axis we can't detect. Mind-blowing, right? But even if the universe itself isn't spinning, here's what we know for sure. Rotation and spin are absolutely fundamental to how the universe works. From the smallest particles to the largest galaxies, spin is everywhere. It's unavoidable. It's eternal. It's what shapes reality. And here's the beautiful thing Feynman realized. Spin isn't just something that happens in the universe. Spin is what makes the universe. Without it, there would be no structure, no galaxies, no stars, no planets, no chemistry, no life, no us. The fact that you exist, the fact that you can watch this video, think these thoughts, wonder about your place in the cosmos, all of it is because the universe spins. You are literally made of spin. Your atoms, your molecules, your DNA. All of it is held together by the quantum spin of particles. You're spinning through space on a planet going over 1,000 kilometers per hour. And every moment of your existence, every breath, every heartbeat, every thought is only possible because billions of years ago, a cloud of gas started to spin. So here's what we learned today. Everything in the universe is spinning. Not because spin is special, but because not spinning is practically impossible. The tiniest disturbance creates angular momentum, and once you have it, it's conserved forever. Earth spins because of angular momentum from the cloud that formed our solar system. Galaxies spin because of tiny fluctuations in the early universe. Even particles have quantum spin that makes chemistry and life possible. Feynman showed us that spin isn't just a random feature of the universe. It's built into the fundamental symmetries of reality itself. The universe has no preferred direction, and that symmetry is why angular momentum is conserved. And spin creates everything. Galaxies, solar systems, magnetic fields, the structure of atoms. All of it exists because of rotation. You're not just in a spinning universe, you are the spinning universe. Made from spinning particles, living on a spinning planet, orbiting a spinning star, in a spinning galaxy. And honestly, that's beautiful. Next time you spin around in a chair, or watch a planet rotate in a documentary, or see a spiral galaxy in a photo, remember, you're looking at the universe doing what it does best. Spinning. Forever. Creating everything along the way. If this blew your mind, smash that like button. Subscribe for more videos breaking down the universe in ways that actually make sense. And turn on notifications because trust me, we're just getting started. The universe has so many more secrets to share. I'll see you in the next video.